Okay, so number 7 first. Okay, question 7. Can someone read to me question 7? Rachel, could you read it to me because your voice is nice?
A pellet gun fires a pellet with a velocity of 355 meters per second, 30 degrees. What is the magnitude of the vertical component of the velocity at the moment the pellet is fired?
Okay, so it's fired at 30 degrees, and that's in the bearing or navigator's degrees. So we know it's 30 degrees of the first northern axis. Oh, and I did ask Mrs. Goodall about, some of you were kind of confused about the 90, 180, 270 reference. She said that when you guys learned the different method where it went backwards, that's in reference to your trigonometry functions and how sine and cosine and tan are graphed. And so it's like a different type of graphing or concept. This is based on northeast, southwest, okay, and that's it. The other method is based on trigonometry functions. You can ask her more but they're two separate things.
But they both use trigonometry?
I use trigonometry because I'm using triangles to find out my answers, but I'm not graphing a sine function or a tan function. Okay? I'm graphing vectors, and I'm using trigonometry to solve the triangles. Okay, good. So, this asks you to find the y function, I think the question does, right? The vertical?
Yeah.
So it asks you to find the vertical vector. So we know this is our overall vector is 30 degrees, and the magnitude is 355 meters per second. So we are trying to find out y. Now, I think that the textbook has the wrong answer for this, because if we were trying to find out y, we need our cos theta is equal to adjacent over hypotenuse. Adjacent over hypotenuse. So I have my cos 30 degrees is equal to y over 355. So when you put that into your calculator, your y should equal 307.439, etc. So to sig digs, your y is 307 meters per second. Did you have something different? Or no?
I just said 178.
Yeah, so I looked at the detailed answers for the textbook, and it used sine rather than cos, which is incorrect because the y function is cos relative to the hypotenuse. That was the textbook's mistake. They used sine instead of cos. So. Yeah.
So you need the direction?
No, because this is using the bearing method, so that it's using that this is 90, this is 180, 270, and 360. So when it doesn't give you north of east or whatever like that, it just gives you the degrees. You know, okay, 30 degrees fits right here. Does that?
So in your answer, you wouldn't have to put an angle in there?
Oh, sorry. You probably understood what I was saying there, but no, I don't think so, because it just said what's the magnitude of the y function. Yeah, and that's just so there's no direction.
You always use that bearing system?
Yeah. What?
You always use it like that with 90 on the side.
Well, you could use this one. What would be the different way to do it?
Like, would it tell you if you were supposed to do it?
Yes.
Okay.
Yeah. if it wrote it differently, it would have said like 30 degrees east of north, and that would still be the same vector. Yeah. Okay. If you did have to put a direction on here, it would just be 307 meters per second north, because the vector is just going north, right? That's the only direction that that vertical vector is going. But it only asks for magnitude. Okay, and then I was asked to do 5b. So we'll do that one next. So 5b. Okay, and 5b says, a swimmer travels in a northerly direction across a 500-meter wide lake. Okay, so I just drew kind of, first for myself, I just drew a, well, actually, no, never mind. I did it and then I erased it. So it's a 500-meter wide lake, and she's like swimming north across the lake, but I know that if I'm looking at the lake, it's 500 meters wide. So yeah, maybe I will draw a circle just to give you a reference. So I know that's how wide the lake is, and she's going in a northerly-like direction, but it's clear that it says once across, the swimmer notices that she is 150 meters east of her original starting point, meaning she drifted northeast. So if she's drifting off northeast and she drifted 150 meters from the original, this is how I would kind of draw my triangle. Then it asks us to find, we're trying to find displacement. Determine distance and displacement. So in this case, the distance and the displacement are going to be the same thing, except just that displacement has the direction added to it. So to find this out, we just use Pythagorean's theorem. So we have our a squared plus b squared equals c squared. And our c, or x here, is our hypotenuse, is what we're trying to find out. So 150 squared plus 500 squared equals c squared. C is equal to 522 meters. So because there was no other directions or things she took, I know that my distance for this, d, is equal to 522 meters. But then I also need to have my displacement for this answer. So 522 meters. Now I have to give my direction. Well, I can figure out the angle here using trigonometry. So I'm trying to find now theta of this angle. To find that, use your trig functions. So I have opposite over adjacent, which I know is tan. So tan theta is equal to opposite over adjacent. So your theta is equal to the inverse of tan times by 150 over 500. So your theta is equal to 16.7 degrees. So I know this is 16.7 degrees. Rounded to our signics, I can say that's 17 degrees. And she has traveled northeast. So this is 17 degrees east of north. Or if you actually just put 17 degrees, that would also be correct because it's on, according to the bearing method, you would, be at 17 degrees. Does that clarify any questions for that one? Any others? Okay. So next, I want you to try to do question number 8. because I thought it was a little bit harder. And so I want you to try this now that you've had all of that other practice. And do number 8, try it on your own. And then I'll go over it with you.